Today's project will be replacing the internal battery on a Korg DW-6000. Unlike some of the other synths I've worked on, this one doesn't give a warning when the battery is low. Here I'm trying out several patches to discover they all make the same sound. This is because the battery isn't holding enough charge to remember the patches after going through a power cycle. If you try to save any patches when it's in this state, it will remember them until you turn the synth off again. To solve this, we'll replace the internal battery. To get inside, the synth will need to be flipped over so several screws could be removed. When doing so, be mindful of the joystick. I lie the synth down such that the joystick lays off the table. There are also two screws that hold in the part where the power cable goes. This needs to be removed as well. With all the screws now out, we could take a quick look inside. Unfortunately, this one doesn't open so easily with the wires holding both sides closely together. Not as easily serviceable as some other synths. But while we were peeking inside, we could see the battery we were going to be ripping out. Unfortunately, I don't have video of me pulling it apart because I did have a bit of difficulty getting a good shot. But now I have the two parts separated, and we have a nice view of the culprit of our memory problem. 4 screws hold down the board into place, so let's get those out of there. With the board removed, we can now move on to the battery. This one was a bit troublesome for me, as you'll soon see. Firstly, the pins were practically bent flush to the board, which made getting all the solder off hard, and then the pins had to be bent straight again. And then here you can see I was also fighting corrosion. It took a bit of negotiating, but it finally comes free. Here's the battery setup I'll be using. It's the same one I used in my Yamaha DX7 Mark I repair. They're really nice and convenient, and you can find these on eBay if you're interested. We'll first have its leads soldered to the board, and then the battery in its holder will be velcroed onto the chassis. The replacement battery is the same kind as the original, a CR2032. A fairly common size, for button batteries that is. The board is labeled until it tells us which vias are for positive and negative. You may be asking, but we have 3 holes here, and we have 2 wires. What do we do about that? Don't worry, 2 wires is all we need. On the top, we have 2 vias for the positive leads. You can use either one. This is because they are essentially the same node. Simply put, they are connected to the same thing with no other connections made between them. The black wire is used for the negative connection, and the red one is for our positive connection. We'll start with the negative, solder it in place, and then do the same for the red. After cleaning up the flux mess, we can move on to figuring out where we're going to mount the new battery. I decided to keep it somewhere close to the board. Moving on to reinstalling the board before mounting the battery. Make sure to clean the surface well to ensure a good bond with the adhesive that's on the Velcro. The synth could also use a bit of cleaning while we're here anyways. Double checking the placement, I'm now ready to move on to adding the Velcro. Once I've stuck the battery holder into place, I place in the battery. And now we are done with that and are ready to put everything back together. The great thing about this synth is that all its connectors are labeled. On the board, you can see these markings like 9A and 11A. And on the end of the wires, you can see they are also labeled. On this one is 11A. So it will be matched with its corresponding connector. 'connector' on the board. Let's fast forward through reconnecting them all since you now know the trick. Some are easy to do with it wide open, but others will have to be done with it partially closed. Make sure the wires get held down back into where they should be. Time to screw it all back together. I forgot to film it, but remember to screw in the part that holds the power cable back into place before putting the screws back in the back. Also, when flipping it over, remember to keep the joystick off the table. The final part is to reprogram it. After a battery branch plate, it has a case of amnesia. This could probably be done over MIDI, but I discovered the manual has a section on how to program the preloaded programs. Doing this manually, I figured would be a great way to get familiar with how to program it. To start, right enable needs to be flipped on. The switch for that can be found on the back. Next, hit parameters so its LED lights up. With the number pad, enter the number corresponding to the parameter you want to edit. The value of the parameter can be entered by either using the slider or the up and down buttons. Continue this for all other parameters. Something that's helpful is the bank hold function. This locks the left digit of the parameter when you're editing several parameters in the same family. Hitting a number on the number pad will only change the right digit when bank hold is enabled. It saves a bit of time, especially since I'll be entering everything in. Once you've entered all the values you need to, it's time to move on to saving the patch. Press the right button. The program screen will then begin flashing the number of the patch you were initially on. At this point, use the number pad to enter the program number of where you would like to save your patch. Once the second digit has been entered, the patch is saved. Continue this process till all original patches are rewritten to memory. Or not. Or by figuring out how to do it by MIDI, or writing your own, whatever you want to do. Thanks again for watching, and have fun tinkering.